Hello class, today we are starting a new book. Our new book is about volcanoes, and so we'll get into looking at that. We are going to be reading about the eruption of a volcano in 1980 in the state of Washington. And there is a video that I posted in Google Classroom that you can watch if you'd like, where you can see what happened during the eruption, and you can also see some of what happened later on after the eruption. So this book is a nonfiction text about an event, but to understand the event, we have to focus on the science of volcanoes. So for each chapter, we'll read the pictures and the captions first, and then we'll go back and read the text. Our first chapter gives the big picture, so it gives the sequence of events that led up to the eruption in 1980. So we'll be paying attention to what comes first, what comes second, what comes next. So the title of our book is Volcano, the Eruption and Healing of Mount St. Helens. The author's name is Patricia Lauber. And our setup on that, we can look at our table of contents on page 4. And it looks like we're set up by chapters. So we have 5 chapters. It will take us 5 days to get through this. And then we can see at the end that there is an index. So that means if there's any particular thing that we want to look at, we can go into the index, find it in that alphabetical list, and then it'll tell us what page number that our topic is on. Scrolling down, you can find this book in our Google Classroom. If you look under Classroom Resources, you'll see a title that says Our Classroom. When you click on Our Classroom, it'll open up to something that looks like a classroom, and you'll find this book on the second shelf or the middle shelf. It'll say Volcano on it. When you click on that, you'll have access to all of the different chapters in the book. So again, let's look at the caption. So we have this beautiful picture here. The caption says, Mount St. Helens in southern Washington state was long considered one of the most beautiful mountains in the Cascade Range, with its gleaming snow-capped peak that formed an almost perfect cone. This photograph, taken in 1972, shows Spirit Lake in the foreground. So this water that you see here is Spirit Lake. If you look close, you can see a bird sitting on the driftwood. And then what you see back here is Mount St. Helens. Let's look at the next page. Again, we'll come back and we'll read this text in just a minute. On the next page, we have a couple of diagrams. This one right here says a volcano is a place where hot, molten rock from inside the earth comes to the surface. Mount St. Helens was built by many eruptions over thousands of years. So down here you have this magma, and magma means molten rock in the Earth's core. Then we have these different layers that are formed when magma comes out and forms lava, and then the lava cools to get different layers. So that's like the different materials that are covering up the thing. Then we have lava, so when magma comes up here, and then once it comes outside the volcano as melted rock, you would call it lava. So lava started off out as magma. Magma is what it is when it's inside. When it comes out, we call it lava. And then we know that this is erupting, so a sudden outbreak of something. All right, and then this over here, we have a map. It shows the Cascade Range in the United States and the periods in which each volcano last erupted. Question marks means that the dates are not certain. Then the letters BP stand for before present. And we can see Mount St. Helens is up here. It shows the last time it erupted is 1980. And then we have a couple of other ones listed, and you can see what dates that those erupted as well. Let's continue. There's lots of pictures in this chapter. Okay, down here we can see it looks like a waterfall. It says visitors enjoyed the sight of wild animals, forested slopes, and clear, cold waters. Go down to the next picture. This is what ash that's coming that we kind of see covering everything. So it says ash darkened the mountain's gleaming peak. Kind of seeing a progression here, I think. The one on the left says measurements with the surveyor's level, so he's using kind of a level here, were made to see if the ground was tilting, a sign of rising magma. And in this picture here, it says when the weather was clear, geologists could monitor the bulge from various faces, such as Coldwater 2. On May 17th, this geologist, Harry Glicken, was joined by another, David Johnston. This is kind of the aftermath, I think, of that eruption. It says Glicken and Johnson visited the bulge by helicopter. Johnston took gas samples. Later, Glicken went off duty, and Johnston took over at Coldwater 2. The next morning, he was killed by the eruption. just have a couple more. And this here says the mountain disappeared in billowing clouds of hot gas, ash, and rock. That's pretty scary. Another picture here is a kind of a map of the area again. It says the red stripes, so these stripes right here, mark the area of destruction caused by the blast. Yellow stripes, so these little yellow stripes on the edges, mark the area where trees were left standing, but they were killed by the heat. So it got so hot that it killed those trees way out there. And then it says the solid red here shows the avalanche path. A couple more pictures. At 8:32 on the morning of May 18th, 1980, an earthquake triggered an avalanche that tore open the volcano and unleashed a searing blast of steam and rock. All right, so now let's go ahead and go back up and read through the text on this and see what other information we can find out. So I'm going all the way back up to page 1. And go ahead and follow along as I read. So the volcano wakes. For many years the volcano slept. It was silent and still, big and beautiful. Then the volcano, which was named Mount St. Helens, began to stir. On March 20th, 1980, it was shaken by a strong earthquake. The quake was a sign of movement inside St. Helens. It was a sign of a waking volcano that might soon erupt again. Mount St. Helens was built by many eruptions over thousands of years. In each eruption, hot rock from inside the earth forced its way to the surface. The rock was so hot that it was molten or melted, and it had gases trapped in it. The name for such rock is magma. Once the molten rock reaches the surface, it is called lava. In some eruptions, the magma was fairly liquid. Its gases escaped gently. Lava flowed out of the volcano, cooled, and hardened. In other eruptions, the magma was thick and sticky. Its gases burst out violently, carrying along sprays of molten rock. As it blasted into the sky, the rock cooled and hardened. Some of it rained down as ash, tiny bits of rock. Some rained down as pumice, frothy rock puffed up by gases. Together, the lava flows, ash, and pumice built a mountain with a bowl-shaped crater at its top. St. Helens grew to a height of 9,677 feet, so high that its peak was often hidden by clouds. Its big neighbors were built in the same way. Mount St. Helens is part of the Cascade Range, a chain of volcanoes that runs from northern California into British Columbia. In the middle 1800s, a number of small eruptions took place. Between 1832 and 1857, St. Helens puffed out clouds of steam and ash from time to time. It also gave off small flows of lava. Then the mountain fell still. For well over 100 years, the volcano slept. Each spring, as winter snows melted, its slopes seemed to come alive. Wildflowers bloomed in meadows. Bees gathered pollen and nectar. Birds fed, found mates, and built nests. Bears lumbered out of their dens. Herds of elk and deer feasted on fresh green shoots. Thousands of people came to hike, picnic, camp, fish, paint, birdwatch, or just enjoy the scenery. Logging crews felled tall trees and planted seedlings. So it sounds like there was a lot of stuff going on that mountain at that time. And it sounds like probably people forgot that it was a volcano. They treated it more like a mountain where they could do a bunch of stuff. These people knew that Mount St. Helens was a volcano, but they did not fear it. To them, it was simply a green and pleasant mountain, where forest of firs stretched up the slopes and streams ran clear and cold. The mountain did not seem so trustworthy to geologists, scientists who study the earth. They knew that Mount St. Helens was dangerous. It was a young volcano and one of the most active in the Cascade Range. In 1975, 2 geologists finished a study of the volcano's past eruptions. They predicted that Mount St. Helens would erupt again within 100 years, perhaps before the year 2000. The geologists were right. With the earthquake of March 20th, 1980, Mount St. Helens woke from a sleep of 123 years. Magma had forced its way into the mountain, tearing apart solid rock. The snapping of that rock set off the shock waves that shook St. Helens. That quake was followed by many others. Most of them were smaller, but they came so fast and so often that it was hard to tell when one quake ended and another began. On March 27th, people near Mount St. Helens heard a tremendous explosion. The volcano began to blow out steam and ash that stained its snow-white peak. Small explosions went on into late April, stopped, started again on May 7th, and stopped on May 14th. The explosions of late March opened up 2 new craters at the top of the mountain. One formed inside the old crater. The other formed nearby. The 2 new craters grew bigger. Soon they joined, forming one large crater that continued to grow during the next few weeks. Meanwhile, the north face of the mountaintop was swelling and cracking. The swelling formed a bulge that grew outward at a rate of 5 to 6 feet a day. Geologists were hard at work on the waking volcano. They took samples of ash and gases, hoping to find clues to what was happening inside. They placed instruments on the mountain to record earthquakes and the tilting of ground. They kept measuring the bulge. A sudden change in its rate of growth might be a sign that the volcano was about to erupt. But the bulge grew steadily, and the ash and gases yielded no clues. So they're looking for this sudden change, but really this isn't suddenly changing, it's changing a little bit slower over time. Let's see what happens. By mid-May, the bulge was huge. Half a mile wide and more than a mile long, it had swelled out 300 feet. On Sunday morning, May 18th, the sun inched up behind the Cascades, turning the sky pink. By 8 a.m., the sun was above the mountains, the sky blue, the air cool. There was not one hint of what was to come. At 8:32, so that's only 32 minutes later after this beautiful morning, and at 8:32, Mount St. Helens erupted. Billowing clouds of smoke, steam, and ash hid the mountain from view and darkened the sky for miles. The eruption went on until evening. By its end, a fan-shaped area of destruction stretched out to the north, covering some 230 square miles. Within that area, 57 people and countless plants and animals had died. Geologists now faced 2 big jobs. One was to keep watch on the mountain to find out if more eruptions were building up. If so, they hoped to learn how to predict the eruptions. The other job was to find out exactly what had happened on May 18th. Most volcanic eruptions start slowly. Why had Mount St. Helens erupted suddenly? What events had caused the big fan-shaped area of destruction? What had become of the mountaintop, which was now 1,200 feet lower? The answers to these questions came slowly as geologists studied instrument records and photographs, interviewed witnesses, and studied the clues left by the eruption itself. But in time they pieced together a story that surprised them. This eruption turned out to be very different from the ones that built Mount St. Helens. And so as we go along this week, we'll be finishing this book a chapter at a time, and we'll find out what really happened there at Mount St. Helens. Okay, your job now is to open up the assignment page, and in that page you have you're already on the assignment page, my mistake. So within this page itself, I'd like you to add 2 things, either in a video comment or in a text comment, 2 things that you've learned from this chapter today. Once you've added that to your assignment page, then you can go ahead and turn that in.